Today's class, we will go for matrix multiplication. From this, we are learning three topics. First one, how to perform matrix multiplication, traditional method, and its time complexity. And next, we will go for divide and conquer method, and we will find time complexity. Let us compare the difference between these two. And I will show you which one is the best one. Next, after that, we will go for Strassen matrix multiplication. Along with that, it's a time complexity, and I will show which is the which algorithm will take less time to compute one matrix multiplication problem. So before starting this class, I will tell you Strassen is the best one among these three. Okay, I will show you uh, why it is best by comparing with the time complexities. So let us go for traditional method of matrix multiplication. For example, I have a matrix capital A and capital B, and whose size is equals to 3 by 3. It's A matrix size, B matrix size is 3 by 3. And before starting matrix multiplication, first we need to remember that matrix A columns should be equal to matrix B's rows. If that condition is true, then only I can do matrix multiplication. If this condition is false, we cannot perform matrix multiplication. So first let us test whether it is matching, whether this condition is valid or not. So when I go for matrix A, which contain 3 columns, when I go for matrix B, which contain 3 columns. So these three both are matching. So it's a time I can go for matrix multiplication. So before writing algorithm for traditional method, I will tell you how to generate one this equation, and we will find how matrix multiplication can be performed. So when I go for this 3 by 3 matrix multiplication, resultant of this one is equals to C. This is C size. Always your matrix is not square. So this size may be different. So let us go for this 3 by 3. To know what is the dimension of this C, this C dimension is equals to number of rows of first matrix E by number of columns of second matrix 3. So the resultant matrix is also 3 by 3. That you should remember. Next, how can I know the C11 value? To calculate the C11 value, so C11 I need to find this one. So first row of this A matrix should multiply with first column of second matrix. These two I need to multiply individual digit. So A11 need to multiply with B11. Next, we need to perform summation operation with A12 B21. So A12 into B21 plus this A13, which is multiplying with B31. So if I perform this equation, what is the result we get? That value is equals to C11. We need to fill this value. Similarly, I am going to find equation for this C12. I never compute for every value from this. Just I will show you only two equations, C11, C12, and I will tell you how to write an algorithm for this one. So C12 is another value we need to calculate. So how can I find this C12? The first row of A matrix is multiplied with second column of B matrix. So what is the value we get? A11 into B12. plus A12 into B22 plus A13 into B32. So when you evaluate this equation, you will get the C12 value. So now similarly, this you need to continue until we will get C33 value. I will write C33 also. Okay. So how can I write C33? This third row is multiplied with this third column. If I do this, then you will get the C33 value. These things learn in the school level itself. So A31 is multiplying with B13 plus A32 is multiplying with B23 plus A33 which is multiplying with B33. So like this you need to evaluate these equations and you will get the C value. So now let us observe how this relation is available. So for example, I will go for the first equation C11. So here 1 and this one. Okay. I am going to represent this first one with I, second one with J. Okay. These two values is matched from this equation. Observe here. So the ith values A1, A1, A1. So how can I write this one? A of I. Okay. So here, not only for this, if you go for this one, this C1, A1, A1, A1. So is this number multiplying represented with I? That I am going to represent it here for this A. Next, if I go for B, I am going to write the equation. So this is the B you have and A I have, and in between I am performing multiplication. See, A two indexes, B two indexes, and in between you have multiplication. So here, this J, this right side J is there. This J value is matched with this column value. See here, this is 1, it is 1, this is 1, this is also 1. If you observe here, this is 2, this is 2, this is 2, this is also 2. Here, 3, this B3, B3, B3. So this is BJ. Why did I write J? Because it is matching with the C's second index. This growth index, this is columns index. This is matching. Now we need to observe one more thing. For every equation, this second index of A, first index of B, these all are same. So this is 1, 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 this is 1. For first column, for these values, this value is K, 1. Next, if you go for this, this is 2, this is 2, this is 2, this is 2, this one is 2, this one is 2. So here also same. Here, this is 3, this is 3, this is 3, this is 3. Next, this one is 3, this one is 3. And if you here, second index of first matrix and first index of second matrix. These values are same for each level. And this value is incremented from 1 to 2, 2 to 3. So if you observe this one, 1 to 2 and 2 to 3. So here also 1 to 2 and 2 to 3. To represent this one, I am going to take another temporary variable, which is K. Okay. Did you understand how did I write this equation? This equation is very important to remember matrix multiplication. Okay. So if you observe this one, what is the I value from where to where it is calculating? From this is I equal to 1. This is I equal to 2. This is I equal to 3. So this I counter is from 1 to 3. Next j counter is j equal to 1, j equal to 2, and j equal to 3. This counter is from 1 to 3. Okay, generally matrix additions, this is represented like an array. When it is array, whose index will begin from 0. But for our reference, I have written this one as 1. You can write 0 also. So here, this I is incrementing from 1 to 3, A is incrementing from 1 to 3. Okay, next, A also incrementing from 1 to 3. Okay, so here, these all are incrementing from 1 to 3. But always our matrix size is 3 by 3? No. This matrix size is n by n. When it is n by n, how it is going to be performed? Let us see. So here, for this case, I am writing simple algorithm. It's I value. For I value, I equal to 1 to up to what number it is incrementing? Up to 3. I equal to 1 to 3. For each step, how many numbers you are jumping? 1 to 2, 2 to 3. Like that you are jumping. So step is 1. I am going to do. Okay. For each I value, j value is counting from 1 to 3 again. For j equal to 1 to 3, for each step, I am jumping only 1. Next, k. I completed, j completed. What about j counter? It has started from 1, it continued up to 3. So for k equal to 1 to 3, for each step, one number I am shifting forward. So this is the way equation iteration is performing. So what you are calculating here? C of ij. So this C of ij I am writing. So C of ij. Okay. So directly I am using. Initially I didn't assign any value. So here before k counter is starting, I am going to initialize its value to 0. And for k equal to 1. So for k equal to 1, this multiplication is performed and copied to C of ij. Next k equal to 2, this multiplication is performed and copied to again C of j. Perform with old sum and result is copies to C of I comma j. So this is going to be represented as C of ij plus A of I k into A of kj. So this is the simple algorithm to perform matrix multiplication. But if it is go for n size, what happens? This 1 to 3, which is going to be replaced with 1 to n. That's it. Okay. I am writing actual algorithm. Let us see how it is going to be performed. So this is calculation is going to be performed traditional method. So directly I am writing algorithm. Just in the previous slide, I explained how it is performing. So algorithm, I am writing which algorithm? Matrix multiplication. So how I am performing? Is it divide and conquer or general method? So for general method, I am writing GM. So to perform matrix multiplication, how many matrices I require? Two matrices. This is A matrix and this is B matrix. And these both matrix sizes as n by n and n by n. So here capital A matrix, capital B matrix, and whose size is n. Just I am going to take it as n. So you need to go for this is square type of matrix. So if it is not square, you need to concatenate zero value depending on your required number of columns or rows. So here, what is the first thing I did? I'm going to iterate, I'm going to initialize three variables I, j, k. Those values are counting from 1 to n. So here, for I equal to 1 to n. For each step, I am forwarding by one step and I am going to do. So what about j? For j equal to 1 to n, for each step, I will go one step forward. Next is C of I comma j, whose value I am initializing to 0. This is the initial value. For each iteration of k, which is starting from 1 to n, including n, for each step, I am one step forwarding. So C of ij is equals to C of ij plus A of ik into B of kj. This is the equation. So let us know how much time it consumes. So how many times this k is iterating? N times. So this equation for this k value, this is going to be evaluated n times. For each j value, this k is iterating n times. So this is also n. For each value of this n, it is going to be iterated n times. If you go for I, for each value of this 1, it is going to be iterated n, j is iterated by n. For each j value, it is going to be iterated by n. So this evaluation is equals to n into n into n. So the time complexity T of size n by n matrix whose time is equals to n cube time. So what is the worst case time complexity? N cube. Okay. So I am going to draw these things on the graph. Okay. So I am going to take this one, and when it is 1, so result is 1. When n contain 2 by 2 matrix, 2 by 2 means 2 into 2 into 2 because n cube na 2 2 ja 4, 4 2 ja 8. So you will get this is 1, this is 5, this is 10. If you take like this, 8 will be at here and will be available at here, whose growth is growing like this. So this is order of n cube line. Is this clear? Next, I will go for another method. So what is the time complexity of general or traditional method of matrix multiplication? Order of n cube. Now I will go for divide and conquer method. So what is divide and conquer method? What is the rule of divide and conquer method? So initially, I am going to take one problem. So if the problem is small in size, directly I am going to evaluate. If the problem size is very large, I am going to split that problem into 2 or more subproblems, and each subproblem is going to be evaluated. This thing we learned in the previous class. So similarly, when I go for matrix multiplication, okay, so I am going to evaluate this matrix multiplication using divide and conquer method. So let us understand what is the first step. So what can I do? Initially, I need to test the problem matrix multiplication E, which is going to evaluate A by B. When a matrix is said to be small, if that matrix has only one row and only one column. If you observe this A11, this is matrix A, which contain only one row, which contain only one column. So how many elements were presented here? Only one element is A11 element. Similarly, B is another matrix. So this B also has 1 by 1 size. This A also 1 by 1 size. So total how many elements were there here? Here is 1, here is 1. How do you perform matrix multiplication? Which is simple which is simple two integer numbers multiplication. So if in case if n equal to 1, what does this n equal to 1 represent? The size of your matrix is 1 by 1. At that time, you simply evaluate A11 into B11. This is the result of C11. So result matrix of C11 is going to be evaluated by multiplying A11 into B11. Okay, this is very smallest subproblem. Next, along with that, I will go for next smallest multiplication. Okay, so if I go for next problem, what is the problem? Capital B, and I am going to evaluate A into B. In this case, A matrix size is 2 by 2, B matrix size is 2 by 2. So these two matrices I have shown at this place. This is capital A matrix. This is capital B, whose size is 2 by 2 and its size is 2 by 2. So let us know. This is also I will consider as a small problem. This one is also considered as a small problem. Okay, let us know how to compute matrix multiplication, and let us know how to find C11 value, C12 value, C21 value, C22 value. So how do I calculate these values? So C11, this result is equals to A11 into B11. So I am writing it here. A11 into B11 as A12 into B21. A12 into B21. So this multiplication I need to perform. So here C12. How can I calculate C12? A11 into B12 plus A12 into B22. This is C2. What about C3? C3 equal to A21. A21 into B11 plus A22 into B21. This is another multiplication. Next, we will go for C22. How can I calculate C22? A21 into B12 plus A22 into B22. So this matrix multiplication is fixed. Okay, because this is also matrix considered as smallest matrix, you are going to perform 8 multiplications. In this case, only one multiplication which take only 1 unit of time to compute matrix multiplication. So if you go for this case, what is this case? If the size of your matrix is 2, means if it is 2 by 2 size, let us know how many single element multiplications will be performed. So here to compute C11, 2 multiplication, 1 and 2. For C2, 2 multiplication. For C21, 2 multiplication. For C22, 2 multiplication. Total 4 into 2 multiplication. 8 multiplications we are performing. Each multiplication will take 1 unit of time. So total it will take 8 units of time. In this case, it doesn't matter what type of elements were present inside this one. Okay. So which definitely perform 8 units of time. It never increase and it never decrease. These two things you should remember. Okay. So which is also taking when your matrix size is 1 by 1, which is taking 1 unit, which is constant time it is taking, C time. And it is 2 by 2 matrix also, which is going to take constant time, 8 units of time it is taking. Okay. But always your matrix size is not 1 by 1 and 2 by 2. If it is more than this size, then what can I do? I will perform the divide and conquer method. Okay. So here this matrix has from 1 to n rows. Okay. And each row has n columns. So I'm going to highlight this one. This is a matrix whose size is n by n. Okay. And is this n is equals to 1? No. Is this n is equal to 2? No. This n value is greater than 2. In this case, I am going to perform division operation. Okay. So let us know how this division is performed. So this division is equally divided. Means this n value is going to be divided into two n by 2 problems. So n by 2 cross n by 2 size. So how it will be divided? This entire matrix is going to be divided into these four pieces. This is n by 2 by n by 2 matrix. This is n by 2 by n by 2 matrix. This is n by 2 by n by 2. This is n by 2 by n by 2. This is only one matrix. Now I am going to give the representation. So this is of what? This is entire A matrix. So I am going to represent this with the capital A 1. So when I write lowercase a11, which means element, okay? When I write capital A11, which is nothing but submatrix. Okay, this representation you should remember. So this is A11, this is A12, this is A21, this is A22. Similarly, I am going to divide this one into two equal parts. So this is B11, this is B12, this is B21, this is B22. So this entire thing is submatrix. This entire thing is submatrix. Okay. So now I am going to write entire algorithm. Let us know how to write this one. So I am writing algorithm. This is recursively performed algorithm. So which algorithm I am writing? Matrix multiplication. Which method? Divide and conquer method. So how many matrices you require? Two matrices. One is capital A and capital B. What is the size of these matrices? N size. Okay. So in divide and conquer approach, what can I check first? Whether it is small or not. So if, how can I represent it is smallest matrix? If value n, if it is equals to 1, what can I do? Simply I am going to return A11 into B11. This one we did in this place. This one. Next. Is this matrix size is always n? Always 1? No. If it is false, I am going to test what is the size of this one. So if the size of matrix is equals to 2, then what can I do? What are the multiplications I have written at here? This everything you need to copy at this place. Okay. C11, C12, C21, C22. So this equation you need to rewrite at this place. How much time it is taking? 1 unit of time. How much time it is taking? 8 units of time. Okay. Either this one or this one. So I am going to represent this one as constant time. This one is constant time. Okay. Next, if these both conditions are false, next I will go for another alternative. Right. So what is the another alternative? So here this capital A matrix is divided into two equal parts. How can I know how much, how many, how exactly half I did? So by knowing the size. So here I am going to find the mid position of this matrix. How can I find? By knowing the dimension. Okay. So this n by, so this is the midpoint. Okay. So this midpoint I am going to calculate. Next I am going to perform division operation. So let us know. Matrix, see here, recursive call. Observe here how I am going to write. This matrix, this is an entire matrix, submatrix, which is going to perform multiplication with this submatrix. So this is submatrix, this is matrix. What values this is getting? Matrices only. So matrix multiplication of divide and conquer approach of this subarray A11, comma, this subarray B11, comma, what is the size of these two matrices? N by 2. Okay. Even you need not to find this one. Directly I am going to take n by 2 at this place. Next. So by calculating these two multiplication, will you get C11? No. So this entire matrix, second half part is going to multiply with this half part. So matrix multiplication using divide and conquer approach of A12 comma B21, size n by 2. So this is matrix and this is matrix. These both are going to be perform addition operation. Next, matrix multiplication of divide and conquer approach. What is the next? How can I get a C12 submatrix? C12 is nothing but this place. To get this place, I want to take A11 submatrix, multiply with B12 submatrix, whose size is n by 2, plus matrix multiplication divide and conquer approach. This is recursive call again. A12 need to multiply with B22. This size is also n by 2. Next, how can I know A21 means C21 submatrix? Matrix multiplication of divide and conquer method of A21, this one is multiplying with this column. Okay. So B11, whose size is n by 2. Yes. How can I know A22? How can I know another multiplication? Matrix multiplication of divide and conquer method. A22 is multiplying with B21 and whose size is n by 2. Next, matrix multiplication divide and conquer method of, I need to know C22 submatrix. This row, this column. So A21 comma B12 whose size is n by 2 plus matrix multiplication of divide and conquer method of A22 comma B22 and whose size is n by 2. So this LC is close. Next, this algorithm is close. So this is the recursive method divide and conquer algorithm. Now let us know how to find the time complexity of this one. So time complexity of divide and conquer method. So here, I want to find the time complexity of this matrix multiplication. Observe here carefully. If n equal to 1, what is mean by n equal to 1? The size of matrix is 1 by 1. So how many units of time you are consuming? 1 unit. Is it fixed or varies? Varies. Fixed. So I am going to represent this one as C, which is going to take constant time. What is mean by n equal to 2? Which is nothing but second smallest matrix. How many units of time this has taken? Only 8 units of time. So what is mean by 8 units? Is it fixed or varies? Fixed. So this is also C. So these two I am going to represent with one thing, that is T of n equal to C when n value either less than or equal to, okay, but it is not less than 2 minus 1. N value should not be minus 1 because we do not have matrix model. Otherwise, we can ignore this term. If n equal to 1, its time complexity is constant. If n equal to 2, its time complexity is constant. If n value is greater than 2, then what I did? We perform division operation. Now we go back. So this division. So in this, how many multiplications you are performing? This is one multiplication. This is one multiplication. Multiplication in single row. Total 8 multiplications. Okay. So 8 multiplication. On what is the size of this matrix? N by 2 size. Okay. We are calculating for n size, but which has when I go for dividend counter, 8 submatrix multiplications are performing. So submatrix is nothing but T of n by 2 plus only multiplying? No. This result, so I am going to highlight this one with other color. This matrix multiplication, this matrix multiplication. These both will return two submatrices. On the two submatrices, you are performing addition. So when it is addition of two matrices, how much time it consumes? Order of n squared. Okay. This one we learned in the previous class. Order of n square it will take. So plus n square time it is taking. What is this represent? 8 multiplications of n by 2 matrices plus n square addition. This is performing. Now, if you, I hope you remember that Master's theorem. Okay. So according to Master's theorem, I am going to write this one. T of n equal to 8 into T of n by 2 plus n square. So which is equals to, this is Master's theorem, I am writing it here. T of n equal to a to the power of k into T of n by b plus f of n. This is the equation. So if I go for Master's theorem at here, this result T of n equals to order of n to the power of log a base 2. This is the result we get. divide and conquer method. Next one. Let us compute this one. P of n equal to order of n to the power of, how can I write this 8? Log 2 cube base 2. And which is equivalent to order of n to the power of log 3 log 2 2. So what is log a base a? Whose value equal to 1. So order of n to the power of 3 into 1, whose time complexity is order of n cube only. So when you apply this divide and conquer method, did you get any benefit? No. Which also take order of n cube time only. Is this clear? So in the last class, in the last slide, I have shown what is the growth of this traditional method. If I go for what is this divide and conquer method also, which is also overlapping this equation. Okay. So order of n cube, this is taking divide and conquer method. This order of n cube is traditional method. Did I get any benefit at here? No benefit. But in the divide and conquer method, the Strassen has given, instead of this 8 multiplication, Strassen has proposed 7 different equations. What are they? There is no any special proof to this. This is P, Q, R, S, T, U, T. These 7 equations, and we need to evaluate this one by using this equation. And to get this C matrix, we need to compute these operations. Okay. So here, this is C11 value, this is C12, this is C21, this is C22. Okay. So let us check whether they are giving correct results or not. Okay. Randomly, I am taking A matrix as 1, 2, 3, 4 and B matrix as 1, 1, 2, 2. Now I am going to compute these values. What is P value? P equal to capital A11. So while I am teaching this division method, I said this capital A11 is nothing but sub array. This case also A11 says sub array. But what is the matrix I have taken, which is 2 by 2? When I go for divide this one, I will get only one element. So the capital A11 is equals to 1 cross 1 size of matrix. Okay. So here A11 is equals to 1. What is this? This method. So is it become small element or not? Doesn't matter whether it is divided or not, that you need to consider. So directly I am writing this 1 plus A22. Is A22 here? 4. 1 plus 4 into B11. What is B11 here? 1 plus 2. So whose result is equal to 5. 5 3 ja 15. Next, Q. I am going to calculate Q. What is Q2? A21, A22. A21, A22 means this 3 plus 4, 7, which is going to be multiplied with B11. What is B11? This is B11. So 1, whose result is 7, PQ. I am going to calculate R. What is R? A11. This 1 is multiplying with B12. This B12. So I'm going to write A11, which is 1, B12. B12 is nothing but this is B1, this is B1 minus B22, this 2. So whose value? Minus 1. Next, PQRS. How can I calculate S? A22? What is A22? 4. 4 into, next B21. Where is B21? This 2. 2 minus B11. 1. So here you get 1. 1 4 ja 4. QRST. How can I calculate T? A11 plus A12. A11 plus A12. So this is 1 plus 2 into B22. B22 is 2. So 3 plus 3 2 ja 6. PQRS U. What is U? A21. A21. This one is 3 minus A11. This one into B11. This B11 plus B12. This one. So 2 2 ja 4. V. Now we need to calculate V. What is V? T of A12. A12. This is 2 minus A22. 4. Next B21. 2. This B22. 2. So minus 2 plus 4. Minus 2 into plus 4. Minus 8. Now I calculated P2 V values. Now I need to find C11. So how can I find C11? So C11 equal to P plus S. So what is the P value? 15. S. What is the value of S? 4. Next minus. What is the value of T? 6. What is the value of V? Plus V is minus 8 and whose value is totally minus 8. Okay. So here 15. 15 plus 4, 19. If I subtract 6, whose value is uh, Yes. So if you compute the values C11, C12, C21, C22, we got these values as 5, 5, 11, 11. And if I go for traditional method, so how can you perform traditional method? This row, this column, we will get C11, C12, this is C21, C22. If I compute this one, I got 5, 5, 11, 11. If you write this matrix also, you will get 5, 5, 11, 11. So these two are matched. So what are the equations mentioned at this place are working fine. So let us know how much time this is required. So if I observe here, total how many multiplications were performing at this place? So here one multiplication, this is second multiplication, this is third multiplication, here fourth multiplication, this fifth multiplication, six, seven multiplication. So how much time this is taking? T of n equal to 7 into T of n by 2 plus f of n. This time it will take. So I'm going to calculate. So time taken to compute n size of matrix. Whose point of view? Strassen's point of view. So who's equal to 7 into T of n by 2 plus f of n. This much time it consumes. So whose value is equals to order of n to the power of log 7 base 2. So which is definitely. So previously what is the value we get? Log 8 base 2. So definitely this one is better than order of n to the power of log 8 base 2. Okay, so Strassen has given uh, best multiplication when I compare with additional method or divide and conquer method. So how this graph growth looks like? So this is going to be reduced some better than this one. This is order of n to the power of log 7 base 2. Okay, so this much growth Strassen has reduced. So this is the way you need to perform matrix multiplication and their time complex. Okay, thank you.